Hello and welcome to the fourth and final part of our fourth lesson in our fifth unit sine functions in our grade 11 University College math class. Okay, we're going to jump right into it. It's going to be crazy. Take your time, rewatch the video if you need to. Let's jump right in. So we have y equals negative sine bracket x plus 40 degrees plus 3. So our a value, our amplitude, is out front here. Now it's a negative, which means that this is going to have a vertical reflection across the equilibrium axis, which doesn't really impact the amplitude itself. The amplitude is still a, so the amplitude is still 1. So we're going to put that in. Our period, as always, is going to be 360 degrees, at least in our University College math class. Now our phase shift. Phase shift happens inside the brackets, but as you recall, this bracket comes with a negative in it. So if it looks like a plus, it is actually negative 40 degrees. So a negative 40 is a phase shift 40 degrees left. And the last one is the constant value. That will correspond to our vertical translation. That is going to be plus 3. So we take that at face value. So that's going to be 3 units up. Okay, and we're going to save our range until the end. So if this were a phase shift to the right, I always recommend just throwing your y-axis just right as far left as you can go. That's going to be a problem here because I want to use this horizontal line that's been given and I don't want to go outside of it. So I need to remember that actually the farthest thing along for me is going to be this 40-degree phase shift to the left. So I'm going to dot in. It's not very vertical. Let me straighten it up a little bit. So we have this vertical line that is actually at negative 40 degrees. So that's going to be our phase shift. That's going to be about 40 degrees away from where we've put, or where we are going to put our actual vertical y-axis. So again, this is a sketch. It doesn't have to be perfect. You remember how far I sort of moved 20 over in this example here. It's just kind of a smidge. So I'm going to do like about twice that, and I'm going to put a vertical axis in right here. That really shows you how poor my first one is drawn. Nonetheless, okay, so there's our 0 degrees. So we have 0 degrees there. Now let's finish up our horizontal scale. Now normally, when we go all the way to the end, we're going to make this 360. But recall that our first point, now again, you don't have to sketch this one on yet because we haven't tackled the vertical translation yet, but our first point is actually going to be here, a 40-degree shift to the left. So our end point, which is normally going to be 360, is actually going to be shifted 40 degrees back that way, which is like subtracting 40 from this. So instead of it being 360, our final point is going to be 320 degrees. Now our middle value, normally we draw this between 0 and our final value, but this time we're doing it, because remember our first point is going to be over here somewhere, so we're going to eyeball about halfway between those two, as opposed to halfway between 0 and 320. So just to get rid of my highlighting jobby there, so that's about the middle right there. I think I should have drawn my point on first. That's not really. Let me fix that up. It needs to be a little bit more over. Okay, so I'm drawing about halfway between the negative 40 and the 320. It looks about there, I think. Now normally this would be 180, but as you recall, we're going 40 degrees back in the other direction, which is like subtracting 40 degrees from it. So instead of it being 180 degrees, this is going to be 140 degrees. So normally, and I'm going halfway between negative 40 and 140, so normally this would be 90, but remember this is going to be 40 degrees less than that. So that's actually going to be 50 degrees here. And remember, halfway between these two is normally 270, but we are going 40 units back in the other direction. So this is going to be 230. Now, we're not really going to do this again in any video, so rewatch this part to see how I just talked about setting the scale of this horizontal axis with a phase shift to the left. If that was pretty good, let's move along. So here we now have to look at setting our vertical scale. Now our vertical scale is going to be a function of our equilibrium axis. Now our equilibrium axis is set at 3. as we can see up there, and our amplitude is going to be 1. So we're basically going to go 1a above that to the highest point, that'll be 4, and 1a below that for the lowest point, and that's going to be 2. So my high point is going to be 4, my low point is going to be 2. So I just need to make sure that I have enough room for that on my graph. And I should probably label that guy. So there we go. So there's 4. I'm going to set it as high up as possible. Halfway between that, I'm going to set 2, and halfway between that, I'm going to set 3. So there's 1, 2, 3, and there's 4. So we have set our vertical scale and we have set our horizontal scale. Now we need to put on our equilibrium axis. So our equilibrium axis is at +3. So I'm going to put that in and dot it as well as I can parallel to the x-axis. There we go, moving along, going to finish up over here at 320, and I'm going to label y equals 3. There we go. And now I'm going to draw on the 3 points that I know are going to be on this equilibrium axis. Now this is important. Remember that not only have we shifted up with the vertical axis, but we have shifted left with the horizontal axis as well. So my first point is actually right here where my where my vertical translation and my horizontal translation have crossed. And now that was the beginning. Once in the middle, they're at 140 in this question, and once at the end at 320 for this question. There we go. It's kind of a loose dot there. Let's tidy it up a bit. Okay. So we have our first, middle, and last ones. Now we are going to consider our high and low points. We know the high one's 4. We know the low one's 2. The question is, which one do we do first? So in this case, we actually have a negative a value, which means that instead of going up first, we're going to be going down first. So at 50, we're going to hit our low point of 2. And at 230 rather, we're going to hit our high value of 4. So there we have our 5 points. Let's draw some lines through this, try to make them curvy. So down we go, and up and down through. Let's get some arrows on those bad boys. There we go. Okay, and now we're going to label all 5 points. So this one here was at -40 degrees. We have a height of 3. At 50 degrees, we have a height of 2. At 140 degrees, we have a height of 3. At 230 degrees, we have a height of 4. I think that was 230. Yep. And at 320, we have a height of 3. So there we have all 5 of our points on and labeled. Now we have to label the function itself, and that's going to be y equals negative sine bracket x plus 40 degrees plus 3. There we go. And now we're going to put on our range. So our high value is 4, our low value is 2. It doesn't matter that they occurred, that we went to the low value before the high value. It doesn't matter. Remember, this thing's going to go off in both directions for eternity. So the set of all y, such that y is an element of real numbers, low value, y, high value. So we know that y will be less than or equal to +4, and that 2 will be less than or equal to y. So there is our last sketch. Now hopefully this is making sense. It is certainly not easy. The benefit, maybe the only benefit, of having these videos is that you can watch me explain it over and over again until you get it. And obviously if you're still stuck after that, you can email me for further clarification and we'll get you where we need to get you. Okay, last little bit of this lesson is building equations of sine functions given pieces of information. So remember that when we have our just raw form, it is y equals a sine bracket x minus d plus c. Now these questions are going to give you pieces of information and you just need to sort of slot them into their appropriate variable. So with an amplitude of 7, that's my a value. So that's going to be, let me just scooch these things around a little bit. I'll move that up. There we go, and I'll write underneath it. So we know that that's going to be a 7. So we have y equals 7 sine. And let's have a look. Do we have a phase shift? We do. Our phase shift is 120 degrees to the left. So for us, to the left, remember, that's going to be minus 120. So we're going to shortcut that, of course, and we're going to make that just plus 120 degrees. And do we have a vertical translation? We do. A VT 15 units down, so we take C values at face value, and that's going to be minus 15. And so that's how we go about doing that. I'll work the other two examples. I'm not going to go slow, but I'm not going to go too fast either. I want to keep this video as short as possible. So let's do one more of these. We have that y equals a sine x minus d plus c. Okay, so we're going to start with this time a reflection across the x-axis. So that just means that whatever a value we have, it's going to be negative. It tells us next that we have an amplitude of 0.15. So let's pop that in for our a. Let's see if we have a phase shift. Yep, so there's our phase shift. That's going to be 10 degrees to the right. So for us, that's going to be x minus 10 degrees. Since that's actually minus positive 10. And then our vertical translation is going to be 4 units up, which we take at face value. There is our second example. The third one, we do have the time for this. Why don't we hit pause, and why don't you try doing this third one on your own? And then come on back, and I'll work through it just so you can see if you did it correct. So hit pause, give it a go, and then we'll see when you come back. Now you're back. Let's finish it up. So we've got y equals a sine x minus d plus c. So it starts off with a reflection across the x-axis. So again, that means that we're going to have a negative, whatever our amplitude is. Our amplitude is 55 units, so that'll be 55 there. Is there a horizontal translation? There isn't, so I'll just pop the, I'll pop the sine x in there. Oh my gosh, I'm forgetting to put the word sine in. Just in the second one. That's terrible. Let me just move that over. Sorry about that, folks. Sine, and then the rest of it is there. Good. There we go, much better. Okay, so we got the sine x, and now in this last example, a vertical translation 25 units down. So we take that at face value as minus 25. So there we go. That's the end. It's a big lesson, big concept. Hopefully it's not too crazy. Now, normally we would go on to do some more lessons online and use an online graphing calculator to work with sine functions, but this is where we're going to end this unit. So make sure that you've got angles of rotation, both positive and negative, and coterminal angles under control. Make sure you understand the sketch of a sine function as well as the transformations to a sine function that change its shape, and then be able to sketch it, which is the last two lessons. So hopefully Unit 5 was awesome, and I'm going to see you in the definitely more review-oriented Unit 6.